Right, hi there. I'm going to start a series of videos which are going to be focused on matrices, more specifically 3 by 3 matrices. Now, the first thing that you might be asked to do is find the inverse of a 3 by 3 matrix. Now, this is procedurally quite challenging. It takes some time, and it is also a requirement of the exam for further maths. So when we talk about what an inverse matrix is, we may start off with a matrix M. So the inverse matrix will be such that if I took the matrix M and multiplied by its inverse, which is denoted by M with a -1, like an inverse function, you end up with the identity matrix. The identity matrix being a 3 by 3, which has the leading diagonal of 1s. So everything else is 0 in terms of the other elements. So there's our identity matrix. Now what it means is if I multiply the matrix M by itself, I get I, but also what it also may mean is M might be a transformation, i.e. it moves a set of coordinates x, y, z onto another point x dash, y dash, z dashed, and then if I perform the inverse matrix it will move it back to its original position. So how do we get about doing this? It's quite a challenging process, but I'm going to go through this step by step. So I'm going to take our generic matrix, which has the elements A1, B1, C1 and so on. Okay, and this is how I would tackle this problem. I would highlight the first row and the first column. Actually you can do any set rows and columns, but the first row and the first column is the way I would start this process. And then I would circle the intersect, which is element A1, and then I'd put two vertical lines around these elements here, which actually denotes the determinant of that minor matrix. Okay, so I'm going to try and find the determinant of B2, C2, B3, C3. Okay, so I'm going to write it up here, B2, C2, B3, C3, and two vertical lines denote the determinant of that. And just a reminder, that is actually represented by, I tend to use a cross, so B2 multiplied by C3, and then subtract the other diagonal product, which is C2B3. Okay, so that's how I'd find the determinant of the minor matrix. And then you would multiply that by A1. Okay, so if I move down to the next slide, what I've effectively done is I've crossed off in red the rows and columns, and I've created the first part of the determinant calculation. Okay, so what I've also got up here is what I call the matrix of signs. Okay, so as you notice, it's got the same number of elements, but it now has a plus, minus, and so on. So what that does is it affects each of the calculations we're going to do. Okay, so for example, if I were to, so this is obviously a positive A1 here, then the next part I would move across, it would be negative B1, positive C1, negative A2, positive B2, negative C2, and so on. So if I show you the next slide, it basically means that my next part of the calculation is I now cross off the first row and the second column, and now we have the minor determinant A2, C2, A3, C3 as denoted over here, and you'll notice also we have a negative sign in front, and we're multiplying that by where it crosses over B1. And then finally, we're going to do the same. This time it's going to be the first row and third column. Again, we're multiplying by positive C1 and finding the minor determinant of the matrix A2, B2, A3, B3. And that will actually make up the entire determinant of our matrix M. So in fact, all of this entire calculation is our determinant of our matrix M that we started with. I'll go through this as an example with numerical values. Now that's only the first part. Okay, the next part is what we do is create what's called the matrix of cofactors. Okay, and I'll do that now. Hi there. So now we're moving on to what's called the matrix of cofactors. So we've done a very similar thing whereby we've blanked off or drew lines through the first row and the first column, and we're now left once again with a minor matrix B2, C2, B3, C3, and we will need to find the determinant of that matrix. And on the right hand side here we have what's called the matrix of cofactors. Okay, now notice I've capitalised A1, B1, C1 and so on. That's fairly standard notation. And once again we have the matrix of signs, which is going to affect what comes out of finding our matrix of cofactors, as I'll explain. Okay, so looking at our first element of matrix of cofactors, we'll call that A1. We block off the first row and first column. So this corresponds to this where it intercepts. Okay, and what we do is we find the determinant of this minor matrix here, which is down here, B2, C2, B3, C3, and associated with our matrix of signs, we put a positive in front. Okay, and that's how we find the first element of the cofactors, and we continue to do that. So we move on once again as before to the second row second column with the first row once again. So we have these two blocked out, and again this B1 element here corresponds to this capital B1 element of cofactors, but this time you'll notice the matrix of signs gives us a negative out in front. Okay, so that will multiply our determinant of that minor matrix. Okay, and we continue to do that. We'll do it for the third element. Okay, so that would be the C1, capital C1. So this is this one here corresponding to capital C1 here. Notice again we've gone back to positive. Okay, and we will continue to do this row by row until we've completely and utterly filled our matrix of cofactors with 9 elements 3 by 3. Okay, and that's our second step towards the process of finding our inverse matrix. Okay, so we're nearly home and dry. So before I move on to finding the inverse matrix of M, I just want to sort of make an observation because this is something that students often get wrong and make mistakes. In fact, I've done it in the past myself. You'll notice we've got, say, going back to our third element, C1 in our matrix of cofactors, we've only got the positive 1 in front. We're not actually multiplying by C1. So previously, when we've actually worked out the determinant, we multiplied through by C1. We do not do so in this case. So if I were to move back a few slides, you'll see that here I've multiplied by A1. Okay, and in the next part we're multiplying by negative B1. Okay, this is what we would need to do when finding the determinant and multiplying by positive C1 here. But when you're finding the matrix of cofactors, that is not the case. Okay, so be wary of that. So moving on to the final part of this long and tedious process, I'm going to determine the inverse matrix as denoted by M minus 1. Now you'll see that we are multiplying first of all by 1 over the determinant of M. We've just calculated the determinant of M, so the reciprocal of that. And we're also multiplying by what's called the transpose of our matrix of cofactors. So here are our cofactors as we've just discussed. Okay, and this thing here, this T, which is outside as almost like an index, this is what's called the transpose. Okay, now the transpose is found by mirroring all the elements through the leading diagonal A1, B2, C3. So we're effectively swapping A2 and B1, swapping C1 and A3, or A3 and C1, and swapping B3 and C2. Okay, so when we do this, we effectively get the matrix on the right hand side of the bottom line, and this thing here, this is called the adjugate, strange term, or the other word is adjoint of our original matrix M. Okay, so this will give us our inverse matrix M minus 1 by effectively multiplying 1 over the determinant of our original matrix M by the adjoint or adjugate of M. So thus M minus 1 will give me my identity matrix I. So a long process. I've done it generically, and now I'm going to do it using actual numerical values from a matrix, a 3 by 3 matrix. Okay, so here we go. So here we are with a numerical matrix 3 by 3. We've called it M, and I'm going to go ahead and work out first of all the determinant, and then move on to work out the inverse. So first of all, what I would do is I would in this case, I'm going to use the top row, so I'm going to use my matrix of signs, positive, negative, positive, and then I'm going to highlight my first column and first row, and I can then put vertical lines around what's left, which is going to basically be my minor matrix, -5, 2, 6, -3, and I can work out that determinant. So off we go. First of all, I'm going to multiply by positive 2. Just for completeness, I'm going to put the sign in front, and I'm going to multiply that by the determinant of this matrix. So it's going to be -5 times -3, and then I'm going to subtract 6 times 2. Okay, I'm going to work it out as I go, and I'm going to move on to the next column. So -5 times -3 is positive 15, subtract 12 is 3, multiplied by 2 is 6. Okay, so my first bit done. I'm now going to remove this and this. I'm now going to do my vertical column, for my second column here, and now I'm going to multiply by -3. And once again, I'm going to find the determinant of the minor matrix, so it's going to be this one here, ignoring the yellow. So it's going to be -3, which is this bit, multiplied by, we're going to do 2 times -3, subtract -3 times 2. Okay, so once again, make this calculation. 2 times -3 is -6. And of course I'm subtracting a negative, so -6 subtract -6 is going to be +6. Doesn't matter, I'm multiplying by -3, it's still going to be 0. Okay, and then finally I'm going to move on to my next column, so I'm going to get rid of what I've highlighted here. Okay, and I'm going to do my third column, circling the positive 4, so that's +4, multiplied by, and here's my final minor matrix. So I'm going to do -3 times negative. I'm going to stop right there and backtrack. I didn't mean to do that mistake, but actually I'm of course going to do 2 times 6 first. Again, that highlights a mistake that can be easily made in this long process, and then from that I'm going to subtract a -5 times -3, which is subtract 15. So 2 times 6 is 12, subtract 15 is -3, multiplied by 4 is -12, and then I'm going to add all those together. 6 subtract 12, get -6. So I can write down here my determinant of M is equal to -6. Okay, so this is my first part of the process. I'm now going to move on and calculate the matrix of cofactors. Okay, so that's my next bit. Okay, so now I'm going to start on my element of cofactors, having found the determinant. So again, I'm going to do precisely as I did before. I'm going to highlight the first column, first row. Okay, and this is going to correspond to my top left element of cofactors. I'm going to call that A1, as I've just described. Okay, and notice our element A1 is affected by my positive in my matrix of signs, and we're left with a minor matrix, negative 5, 2, 6, negative 3. So I can find A1 is just equal to, remember, I do not multiply by 2 in this case. I simply find the positive value of my determinant, negative 5 times negative 3, and then from it subtract 6 times 2. So I end up with negative 15 subtract 12. So I end up with negative 3, positive negative 3, obviously giving me negative 3. And now I'm going to move on to find my second element. Okay, so I'm going to move on to my second column, and that's going to correspond to A2. Once again, not multiplying by 3, but I am considering my negative in my matrix of signs. So A2 is equal to negative, and I'm going to find the determinant of my other matrix, my minor matrix, 2, 2, negative 3, negative 3. So I'm going to go ahead and do this. I know what the result's going to be. It's going to be 2 times negative 3, subtract negative 3 times 2. Okay, so that's going to be negative 6, add 6, regardless of what I multiply that by, it's going to be 0. And then finally, again, I'm going to highlight my third column, which is going to give me my corresponding element of cofactors A3, and this is going to be affected by my positive sign here. And again, I'm going to find the determinant of my matrix, my minor matrix. So A3 is going to be equal to positive, and we're going to do negative 3 times negative 5. Okay, and from that I'm going to, you see, I did this a second ago, and again it just highlights how easily you can make mistakes. Okay, so remember, we're actually multiplying 2 by 6 first, and then subtracting from that negative 3 times negative 5. And obviously that makes a sign error, which is without doubt the biggest issue in errors in any kind of further maths calculations. I can always guarantee that if I backtrack through some students' work, it's going to be a sign error. So 2 times 6 is 12, and then negative 3 times negative 5 is positive 15. So 12 subtract 15 is negative 3, not being affected by the positive sign there, so it just becomes negative 3. Okay, so if we imagine our matrix of cofactors now, I'm going to put it up here. My first 3 elements are going to be negative 3, 0, negative 3, and then I'll continue this process until I filled it out. I'm going to do a kind of a typical bakery thing here and kind of take it out of the oven if you want, and fill in the rest of them without actually manually doing it. Okay, so just so that you get the idea of the process. So just like out of a cookery program, here's one I prepared earlier. It's the matrix of cofactors. I'd already calculated the top 3 and I filled in the rest. For those among you who noticed my mistake, not deliberate, it was a sign error. This should not have been negative 3, because looking at the calculation, it's negative 5 times negative 3 is positive 15, subtract 12, which is positive 3. So that addressed that small issue up there. These aren't penalised hugely in papers for exams, but obviously they're going to have knock-on effects for subsequent parts of the questions. And it's the most common mistake that you'll see and you'll make in any A-level further maths paper or questions. It's sign errors. Okay, so we've now addressed that mistake, and we're now going to take my matrix of cofactors and we're going to transpose it. So if you remember, a transposition will involve drawing a leading diagonal from 3 through 6 and negative 16, and we are going to swap or mirror the elements of my cofactor matrix. So we're going to swap 33 and 0, 26 and negative 3, 4 and negative 21, and leave everything else as it is. and what we'll end up with is our adjugate or adjoint matrix. So I would normally write the 3, 6 and negative 16 along my leading diagonal, and then swap things over. Hopefully I won't make any mistakes. So 0 and 33, 26 and negative 3 swap over, so negative 3 is there, 26 is up here, and then finally 4 and negative 21 swap, so that's going to be negative 21 there, and 4 up here. Okay, so there's my transpose matrix, transposing my matrix of cofactors, and now I'm just going to finish this off. So let's get rid of all of that working, and I'm now going to finalize my inverse matrix of M. So M minus 1 is, if you remember, my determinant was negative 6, so I take my reciprocal, multiply that by my adjugate or adjoint, and making sure that I correctly copy down my values. Another easy point where you might make a mistake. And what I'm going to do, which is fairly standard, is to multiply my negative 6 through into my matrix and simplify things. So along my top row, we end up with excuse me, negative a half. 33 and 6 both divide by 3, so it's going to be negative 11 over 2, and 26 and 6 both divide by 2, so it's going to be negative 13 over 3. And along my middle row, it's going to be 0 clearly, and then negative 6, 6 is negative 1, and then negative 4, 6, negative 2/3. And then finally my bottom row is going to be positive a half, negative 21 and negative 1/6 is going to be positive 21 over 6, both divide by 3, so it's going to be 7 over 2, and then finally it's going to be positive 8 over 3. Okay, so there is my inverse matrix. Let's just kind of give a bit more symmetry to the brackets. Okay, so that was a long process with the likelihood of many errors, which I made a couple along the way. So as I say, it's quite a long process. It's fairly formulaic, and it will come up undoubtedly in an exam, whether it be paper 1, 2 or 3, and it will be probably worthy of 8 marks. So I'm now just going to check that this actually does actually do what it's supposed to do when multiplied by M and give you the identity matrix. Okay, so we've got our matrix M and the inverse matrix M to the negative 1, and what I'm going to do is I'm going to go through the calculation of multiplying the two together. So effectively what I'm going to be doing here is going to be doing M multiplied by M minus 1. Well, I'm not going to do the whole thing, I'm going to do one row just to remind you how the calculations work. Okay, so if I were to highlight my top row of M and my first column of M minus 1, the calculation would basically go 2 multiplied by negative a half plus 3 multiplied by 0, and then finally plus 4 times a half. Okay, and that would give me my first element of my product of M and M negative 1. So 2 times negative a half, I believe, is negative 1, plus 3 times 0, I hope is 0, and then finally 4 times a half is plus 2, so that gives me 1, which is hopefully what I was expecting to get for my top left element of my product of the two matrices. So I'm going to go ahead and finish the calculation using a web tool just to see if we get the full result we want. So as you can see, I've pre-programmed the elements of matrix M, which is actually called matrix A in this case, and the inverse matrix, which is called B, which is actually the matrix was just calculated, which was M to the negative 1, and you can see the fractional inputs. So if we find the product of these two matrices, which means I've just got to press calculate, we're looking for the identity matrix. So fingers crossed this comes out with the identity matrix that we're looking for.
Okay, so as you can see, we have an output matrix which has a leading diagonal of 1s, okay, and everywhere else is zeros, which is the identity matrix. So we've figured out the inverse matrix correctly. Okay, thank you.